This is Algebra Lesson 3.1, Proportions. So a ratio is just a fancy word for fraction. We have a number on top that we call the numerator, a number on bottom that we call the denominator, and they show us the ratio or the quantity of how much we have of one item compared to another item. So we could be comparing things like how many times a fan turns based on how much time goes by, or how much milk a cow can produce. But we're comparing two quantities to each other. A proportion would take two of those ratios and set them equal to each other. There we go. So calculate the unit rate. So unit rates are basically you just take the numbers and you divide them. But you do have two options. You can always divide one way or then reverse your fraction and divide them the other way. So it's sometimes easy to figure out how to divide, sometimes a little difficult. So if you're talking about like a speed, the advice is to always put the time on the bottom. And if you are talking about something like a price, should usually go on the top. Otherwise, you kind of have to read it and see what unit makes more sense to you. So this first example here says, find the unit rate of a computer fan that rotates 2,000 times in 40 seconds. This is a speed. I see a time measure here, which tells me that that should go on the bottom. So my two possible units would be times per second or seconds per time. So do I want to know how fast it's going? I would take 2,000 times divided by 4 seconds to get that thing is traveling at a rate of 500 revolutions per second. Maybe you've heard of RPMs. They measure like a car's speed with RPMs. So a fan speed, RPS. 12 cows produce 224,988 pounds of milk. So this is one where we could say, do we want to know how much milk one cow produces, or do we want to know how many pounds we need, or how many pounds would give us one cow? And I think if we do our pounds per cow, that makes more sense than cows per pound. So our pounds per cow is not a calculation that I'm going to do off the top of my head, but good thing I have my handy dandy calculator here. And that tells me that one cow produces about 18,749 pounds of milk. So 18749. 18749. I'm going to go underneath because I'm kind of taking up a lot of my space, but pounds per cow. And the last one says a yellow jacket can fly 4.5 meters in 9 seconds. We're trying to find the speed, so the time value would go on the bottom. So this will be 4.5 meters over 9 seconds. I think I'm going to go decimal here rather than fraction, but that would be 0.5 meters per second. Letter B, determine if the proportion is true or false. So I have a fraction or a ratio equal to a second fraction or ratio, and to determine if they're true or false, I like to use a method called cross products. So if I multiply down the diagonals and those answers are the same, then it's true, and if those answers are different, then it's false. So on the first diagonal I drew, 8 times 3 is 24, and on the second, 2 times 12 is 24. Those are equal, so this is true. My next one 8 times 2 is 16. 3 times 12 is 36. Those are not equal, so this is false. Now this is just one method to determine true or false. You could also divide and see if those are equivalent, but I feel like multiplying on the top of your head is a little easier than dividing on the top of your head. So I feel like this is a faster method for me. But here I got 3 times 8 was 24. 2 times 12 is 24. So that are equal, and that is true. Letter C says, find the value in each proportion. So I have a bunch of examples here, and I'm going to show you two methods that you can choose what works best for you. The first one is called the fish method. So I have 2/3 equals something over 6. You would start at the number either above or below your variable. So here I would start with 6, that's right below my variable, and we draw a fish. So we would diagonal, straight down, diagonal, and it kind of makes a fish shape when you draw it out. So that tells me where to multiply and then where to divide. So I would do 6 times 2 divided by 3 to tell me the value for m. 6 times 2 is 12. 12 divided by 3 is 4, so m is 4. I'm going to do that one again. I would start wherever my variable is, right underneath that. 19 times 56 divided by 133 gets me to my answer. 19 times 56 divided by 133 gets me to my answer. Those are some larger numbers, so I'm going to rely on my calculator to do this one a little faster rather than write those out the long way. 19 times 56 divided by 133 is 8. N is 8. And one final problem using the fish method. 12 times 132 divided by 176 gets us to our answer. And I'll leave it up to you to see if you can do that one. For the bottom three, I'm going to use the cross products method, which is a little more similar to what I did on example B, but you would find the two numbers that you know diagonally. I can't really multiply 35 and Q. I don't know what Q is, but I can multiply 21 by 20. So what you're ultimately doing is the exact same thing as the problem before, but the representation to help you remember what the steps are just looks a little bit different. So you would multiply diagonally the two that you know, and then when you have that answer, you would afterwards divide by 35. So it's really the exact same steps. We're still multiplying two numbers diagonally and dividing by a third. Just how it looks, how you remember which direction to go, changes a little bit. So 21 times 20, and then divided by 35 is 12. I'm going to write out the last two without actually doing the work, and you can feel free to do that work and check and see if you can do these on your own. Obviously, then there's more practice problems on the page that follows. And I have one final example down here. We have a word problem. Letter D says, Jacob estimates that 2 out of every 3 students will attend the class party. He knows there are 750 students in his class. Set up and solve a proportion to help him estimate how many people will attend. So I see 3-ish numbers. I see one number here for sure, and I also have 2 numbers in print. So I have 3 numbers, and then I'm trying to find my unknown, how many people will attend. So I know I'm going to need to do a proportion to solve this, but sometimes it's difficult to know where to put what. So I like to add labels on there until I really get the hang of what goes where. So on the top, we would put party attenders, and on the bottom, we would put the whole group. And then this would be maybe what Jacob thinks, and this would be the actual. So just some labels to help me put stuff in there. So how many does Jacob think is going to go to the party? Well, he thinks 2 people are going to go to the party out of all 3 that there are. He knows that there's 750 in the whole class, so there's actually 750 in the whole class. And now my how many is going to come how many actually go to the party. With my labels there, it's a little easier to set up by numbers, and now that it's set up, I would solve it exactly the same as above. Cross multiply divide to get me to my answer of x. 750 times 2, and then that answer divided by 3 would be 1,500 divided by 3. So we think that about 500 people are going to this party. That is it for our notes. Good luck on the exercises, and please let me know if you have any questions.